This footage documents a series of performance tests comparing two horizontal fire shutter assemblies, one constructed from steel, the other from fabric. Both assemblies span an 18-foot wide opening and are installed in the horizontal plane, simulating conditions typically found in atrium separation or floor penetration scenarios. The purpose of this evaluation is to observe how each system responds to water exposure, vertical impact, and static loading. The first test simulated sprinkler discharge to assess how each shutter handles dynamic water exposure. 4 hose heads were positioned at the corners of each test assembly. Water was applied at full pressure to replicate overhead sprinkler activation during a fire event. The test focused on 2 primary factors: whether the curtain retained engagement within the side guides and how the system handled water accumulation. During this test, the steel fire shutter was exposed to a full sprinkler discharge. Throughout the duration of the test, there is no visible deflection of the curtain or signs of water retention. Structural integrity is maintained for the length of the test. The fabric fire shutter was also subjected to a full sprinkler discharge. The test simulates exposure to overhead suppression in a fire-rated corridor. After several seconds under the sprinkler flow, the curtain fails. Here, the curtain is seen detached and collapsed on the floor. The failure occurred at the side guide attachment, where the mechanical roller retainer system disengaged under the accumulated weight of the water, allowing the curtain to pull free and drop from the side guide assembly. The steel shutter features a design that directs water toward the perimeter, utilizing the side guides as integrated drainage channels. The fabric shutter lacks a comparable drainage method and does not incorporate rigid side guide retention features. The second test simulates an impact load event, intended to replicate conditions such as a person or object falling onto the deployed shutter during an emergency. For the steel shutter, a 250-pound weight was dropped from a height of 15 feet. This load was selected to approximate the average weight of a firefighter in full protective gear. After lifting the weight to the predetermined height, the steel shutter underwent the impact drop test. The shutter absorbs a direct hit from the free-falling weight, secured in its side guides on impact. Multiple angles confirm that while a dent was recorded at the center of the curtain, there was no structural failure at the side guides. The shutter remained supported and retained its position. The focus of this test was not only structural deformation, but also whether the curtain remained seated in its side guides under a concentrated vertical force. Given the lighter construction of the fabric curtain, the test load was reduced to 25 pounds, representing 10% of the steel test drop. The same drop height was used to preserve impact velocity. The objective was to determine whether the curtain could absorb even a scaled-down impact without detachment or material failure. In contrast to the steel shutter, the fabric system fails under a significantly lighter load. The mechanical roller retainer system sustains visible damage, unable to resist the downward force. The failure occurs at the point of side guide engagement, resulting in a complete release of the curtain. The final test applied a uniform static load to the steel shutter to evaluate its capacity to bear prolonged downward force across the entire span. 84 5-gallon buckets were distributed across the shutter surface. Each bucket was filled to a target weight of 45 pounds, resulting in a total distributed load of approximately 3,780 pounds. The equivalent load and pressure was calculated at 36.5 pounds per square foot. This test condition simulates scenarios involving water accumulation, debris buildup, or compressive force from above during a structural event. The test focused on deformation behavior and continued guide engagement under distributed pressure. This procedure was not conducted on the fabric curtain due to its extremely limited load-bearing capacity. The assembly could not support even one full bucket without detachment. As weight is gradually applied, each of the 84 buckets is filled to capacity, 45 pounds per bucket, totaling nearly 3,800 pounds. The footage accelerates through the loading process, revealing gradual deflection at the center of the shutter. Despite the increasing load and visible flexing, the structure maintains full integrity throughout. No signs of buckling or structural compromise are observed, even at maximum capacity. From the sprinkler exposure to the dynamic impact testing, each phase of evaluation demonstrates one critical truth. Not all horizontal shutters are built the same. In horizontal applications, maintaining side guide integrity is essential. Failure there can lead to catastrophic drop or disengagement. And in horizontal configurations, the stakes are even higher. Structural strength isn't optional. It's the foundation of fire and life safety. And that's why this steel shutter can still hold the weight of 10 people standing directly on it. Because in the field, strength is not a feature, it's a requirement.